and they say, you know, when Frankie sleeps, he make a lot of effort and he snore a lot. And the pediatricians say, that's okay, every child snore. That's not okay. And Frankie was short, could not put on weight because he was making all this effort during the night. You are not supposed to run a race when you sleep. If you run a race, you use a lot of energy and you are going to use all your reserve. If during sleep you are supposed to rest, be quiet. If you run all night, you are not going to be great in the morning. So that's, in a nutshell, yes. I will advance from here. So this syndrome has been called obstructive sleep apnea syndrome. Okay, and there have been definitions. When you completely stop breathing, it's called an apnea. And it was said that the minimum that you should stop is 10 seconds. And then if you don't completely stop, it's called hypopnea, meaning partial apnea. But today, there is a lot of controversy about this problem. So there is, that's okay.
Let me see.
Okay.
Yeah, you can move.
Okay. So there is a certain amount of controversy about what is an hypopnea. However, about 30 years ago, people decided that if you had this type of problem 5 times per hour, it was not good. But today, we know that that's probably not a very good way to look at what's happening when you are sick. You see, this is on the girl. We put a tube and we put a tube through the nose and we look down. And here is the base of the tongue and at the back of the throat. And you look down, it advances by itself. Okay, if you take a movie, that's what happened. You see, when she cannot breathe, it's because the wall of the size of her windpipe, of her upper airway, are collapsing. And the collapse, here is a vocal cord, but you can see that everything is collapsing. And here you have complete obstruction. And that's what was happening to that girl. Sometimes, you see, you don't completely close. You see here, there's still an opening. And that's being called an hypopnea because if you measure oxygen, and unfortunately today, we have a very easy way to measure oxygen at a finger. It's called an oximeter. And it's called a pulse oximeter. There is a relationship between what we call saturation, which is looking at one way to measure oxygen, and tension, which is a better way, but is much more difficult to measure. So people looked at decrease in the size and drop in oxygen and say that's an hypopnea. However, sometimes people stop here, and you can see sometime here, and you can see that that's not really a well-opened airway. So when you stop here and when you stop here, you already have problem. But this problem has not been for a long time very well studied. So what we do when we want to study someone with this type of problem, we do a test. And this test has been called a polysomnogram. And one of the problems is that everybody believes that they can read the polysomnograph. Actually, it's not true. You need to be well trained, and you need to know what is normal and what's not normal. Here is a polysomnograph. As you can see, you have the brain wave. You have study of the muscle, that's the muscle of the tongue. That's the eye movement, and that's the flow at the nose and the flow at the mouth. That's the rib cage muscle, that's the abdominal muscle. Here we were monitoring the diaphragmatic muscle, and here we monitor the abdominal muscle. And here is the oxygen saturation. And you can see that here there is a stoppage of air exchange despite the fact that the belly and the diaphragm are moving. And you can see that the diaphragm is moving, but there is no air exchange. Exactly what you see on the video. The little girl is trying to open to breathe, but there is that closure which happened in her throat. Okay? So that's what we call an apnea, because there is no air exchange and the saturation of oxygen drops. Okay? But there are some problems, as I say, because this definition, as I show you on the slide, do not realize that all the pathology is well described. So there is today a lot of controversy on what is called an hypopnea. And this is important because it has consequences on the treatment. For example, you see perfectly well that on this slide, here is the air exchange, and there is not a complete stoppage. But you can see that that's a normal breath, that's a normal breath, that's a normal breath, but in between there is a decrease in the air exchange, but not a complete stoppage. And this is associated with this big burst in the brain wave. You look at the oxygen saturation, which is here, and normally you, for example, will be between 98 and 99% of oxygen saturation during sleep, sometimes 97, but you see the person is not dropping very much oxygen, but there is a problem and there is that impact on the brainwave. And that's where we are. You see, you can do computer system to recognize there is no air exchange and there is air exchange. But that's not enough. What we want now is to have a system we can recognize what we call this flow limitation, because that's going to have an impact in your brain. So there is something which was defined which is called flow limitation, which means exactly the word, the limitation of the flow. We have a nasal cannula. You saw it on the little girl. She had it in front of her nose. And there is a curve. And we looked at the wave counter of that curve. We can also put a tube inside the throat, which goes in the esophagus, close from where the diaphragm is. And as you have seen, we can monitor the diaphragm activity. It's a bit more invasive. When you put a tube in the nose, people not necessarily sleep very well. Okay? So that's a normal breath. You see, that's how, with this sensor, how the breath should look. But sometimes it looks like that. Okay? So it's not a disappearance of the breath. Sometimes actually it doesn't look like that, but it looks round and the peak is there. What does the peak mean? It's mechanical. So you start making a good breath, but everything is closing, so you cannot have a normal breath. You cannot have a normal shape. Or sometimes it starts closing at the end of expiration, and you make more and more effort. So making more effort is going to go, and you are going to have a little peak there. here is another example. You see the curve is, instead of having a very nice round breast, everything is cut. And if you look at that's at a different speed, but you can see that in association with what we call flow limitation, you have the brainwave that change. The important thing for us is what are the consequences of this abnormal breathing, because that's what the problem is. So these type of analysis are more difficult to do, and particularly what we want is to have computer program who can look at, you know, if we look at by 30 seconds, if you sleep 7 hours, it's a lot of data. Or if you look at each breath, it's a lot of data to look at. So we really want to have good engineering to look at this type of approach. There is only one program in the world which was developed in Iceland, which look at this flow limitation. Okay, here. So one other thing also that we know is if you take your pulse, you are going to see that you are around 50, 60 heartbeat per minute. Well, it's the same if you look at respiration. When you are asleep, normally you breathe about 16 breaths per minute. And there is one thing is when you run, you are going to increase your respiratory rate. And there is a relationship between the respiratory rate and the amount of oxygen or air that you put in your lung, which is called tidal volume, and you should keep your oxygen normal during 1 minute, and that's minute ventilation. It's a very simple formula. If you decrease your tidal volume for any reason, you can help yourself by increasing your respiratory rate, okay, with that formula. You will keep your minute ventilation normal. But I mentioned to you at the very beginning, you are not supposed to run a race when you sleep. So you should be quiet, 16 breaths per minute. But if there is something which, like for Frankie, he's going to do because his lung volume is reduced and he's trying to survive. Children are the people who try to survive the most. They fight a lot. Okay? So here is Frankie. You see, he is, it's all slide. He's 7, and you can see his brainwave. He's snoring all the time. But you see, he doesn't stop breathing, but he breathes very fast. If you look at his respiratory rate, it's about 36 breaths per minute. Okay? Well, that's too fast. We treated Frankie, and that's 2 months after the first one. And you can see clearly that he's not breathing as much, and you can see that he's breathing about 16 breaths per minute. You see, that's before, that's after. What did we do? Well, we took his tonsil out. So that was, there was a problem inside the throat of Frankie that we could cure. Okay? One other thing that you have to realize is that a lot of people, when they sleep, they don't know what happened. They are asleep. So very often is the person who is complaining is the bed partner or the family. And they say, look, you snore. They don't see the rest, but they can hear the snoring. You make too much noise, or you are sleepy during the day, like the young man over there, who is yawning like hell and falling asleep. Okay, so these people are not slept enough the night before. They are having a problem. Okay, I want this thing go too fast. So one other thing that what can this type of problem lead to? First, sleepiness, not being alert. You see, if you